Alright, let's work through some of these problems that we have to solve, which are related to the Schlenker and McKern Introduction to Engineering Mechanics, and we're on the friction problems, which are chapter 8, and we'll start with 11. So we've got a block of stone, mass of 100 kilograms, resting on a horizontal concrete path. Work out the horizontal force P, there it is there, pushing force, necessary to cause the block to slide if the coefficient of static friction is 0.5. Well, this is quite interesting. How have we got to push to make this thing move? And we've got a coefficient of friction of 0.5. Okay, so this is 811. Let's get this done. Now, we know that the frictional formula is Fr equals mu times N. So here's our block. Our block is 100 kilograms. It's on a surface, and we want to push it here. Now we know that we're going to have a 1000 Newton force, which is 100 kilograms. I should put the extra zero in there, so it's 1000 newtons. Force acting downwards, which means that we're going to get a reaction force of 1000 newtons acting upwards. We have a force P pushing, and of course we're going to have a resistance force pushing in the other way, which is a friction resistance force. That friction resistance force will be mu times the normal reaction. Well, mu we've told is 0.5. That's the relationship between the two surfaces, multiplied by the normal reaction, which is 1000 newtons. And that tells us we're going to have 500 newtons is our maximum frictional force. So therefore P would have to be greater than 500 newtons in order to move the block. Does that make sense? Yeah. Alright, now let's look at the next one, 812. Now in 812's case, we've got an effort of 10 newtons is required to cause a 4 kilogram block to be on the point of sliding. There it is, part 1. An effort of 10 newtons. What is the coefficient of static friction present between the block and the plane? Alright, well, we have a block of 4 kilograms, so that means it's going to be acting with 40 newtons downwards, which means the reaction will be 40 newtons upwards, and that's N, because that's the normal reaction. We know that the force necessary to move it is, we said, 10 newtons. So what is the coefficient of friction? That's the question. Okay, well, let's use our formula again. The frictional force is equal to mu times N. Now in this case, we want to know what mu is. So mu is going to equal to frictional resistance force times N, divided by N, I should say. Now we know that the force necessary to make it move has to be 10 newtons, which means that the frictional resistance force can only be 10 newtons or less. So we're going to assume it's on the point of moving, therefore the frictional resistance force would have to be 10 newtons, because it tells us here it's going to start moving with 10 newtons of force. We know that the normal reaction force is going to be 40 newtons. Therefore the coefficient of friction has to be 10 on 40, which is 1 on 4, which is 0.25. There's no units because it's just a coefficient. So there's the answer there. Let's do the next one, 813. Can you see it here? I'll try and move it back a bit, make it a bit easier for you. There you go. So 813 here now. Oh, we didn't do part 2. You should have reminded me. Okay, part 2. So part 2 is determine the effort E, there it is, just to move the block if a 2 kilogram mass is placed on top of the 4 kilogram mass. So okay, so now we've just got a bigger mass. Now we know what the coefficient of friction is, so mu equals 0.25. We've worked that out. Yeah, mu is 0.25. We want to know now what the effort E is. Well, the effort's going to have to be equal to the frictional resistance force, so we don't know what that is yet. But we do know what the normal reaction will be, because that's now going to be 4 kilograms plus 2 kilograms, which is 6 kilograms. multiplied by 10 meters per second. So that's going to give us 60 newtons. So now we know what the coefficient of friction is, we know what the normal reaction force, because it's the same reaction as the weight force of the object. What's the frictional resistance force? Well, let's do it here. Fr is going to equal to 0.25 mu times N, which is 60 newtons. And what's that equal to? Well, 15.3 it says here, so 15 newtons if I'm using 10 meters per second. Okay, there's your answer. So that means that we need 15 newtons to move it when the extra weight's put on top, which makes sense. More force pushing down, more friction. Right, 8.13. Diesel locomotive is on a track. Given that the mass of locomotives is 45 tons, find the greatest drawbar pull that the locomotive can exert if the coefficient of friction between the wheels and the rails is 0.2. So, okay, in other words, how hard can we push on these, can the forward force go before the wheels will start to slip, before it'll overcome that coefficient of friction? When will the wheels start to skid, basically? Alright, so again we've got a, what do we know about this? We know that the mass of the object is 45,000 kilos, and that's going to give us a weight of, well, 450,000 newtons, because we've got to multiply it by 10 meters per second, which is going to say 450 kilonewtons. Alright, so that's the mass force acting downwards. The next thing that we know is that the coefficient of friction, mu, equals 0.2. So now what we're looking for is a frictional resistance force that the track can produce at this coefficient of friction before the wheels start to slip. Well, Fr is going to equal to mu times N. Now the normal reaction is going to be exactly the same and opposite to the weight force in this case, because we're talking about something sitting on a horizontal plane. So it's going to be 0.2 times 450,000 kilonewtons, and 0.42 times 450,000 is going to equal to 90 kilonewtons. So the maximum frictional resistance force that can be exerted by the rails against the wheels is going to be 90 kilonewtons. Okay, that means that anything that it's towing that produces a bigger resistance than 90 kilonewtons, the wheels will slip. Okay. Alright, 8.14. Let's do it, this last one. We've got a book of mass 1.5, I like this, is held vertically and prevented from falling by being grasped by the fingers of one hand. So what minimum clamping force must be exerted by the fingers if the coefficient of friction is 0.25? Okay, so let's just draw this one up. It's always great to draw a little diagram. We've got a force pushing in here, force pushing in there. We've got a weight force acting downwards. Are there any other forces? Yes, there's a frictional resistance force here and a frictional resistance force here. We'll call this Fr, and we'll call that Fr as well. So there's the force clamping of the hands. Here's the book. Now the book is 1.5 kilograms, which if you multiply that by 10, you're going to get 15 newtons. So we've got a 15 newton downward force. We've got a coefficient of friction here. Mu is going to equal to 0.25. It's the same thing on the other side. Mu equals 0.25. Okay. So now what we need to find out is what minimum clamping force must be exerted. So we want this, let's call it N, the clamping force. What's the minimum before it starts to slip? Okay, well you can probably see that's kind of like a double version. If I just turned it over on its side and I split this little area up down the bottom here and got rid of it, you can see we've almost got the same thing as this over here. But we've doubled it from both sides because we're clamping on both sides now. Okay. Well, what we can say is, looking at this, summing all the forces that are vertical, and they have to, will make upwards positive, have to equal 0, we'd have to say that 2 times Fr, because there's 2 lots of it, has to equal or minus 15 newtons equals 0. That's all the vertical forces. Alright, minus 15 newtons equals 0. And we know the 2 horizontal forces have to balance, so these two have to be the same. Okay. But we have another trick up our sleeve. We also know from our friction equation, but Fr equals mu n. So this Fr here we can substitute. So let's call that equation number 1 and that equation number 2. So putting 2 into 1, substituting this truth, Fr for mu n, we can say 2 times mu n minus 15 newtons equals 0. So what we're trying to do is just get rid of the unknowns and just keep one unknown there so we can solve for it in the equation. In this case it's n. Now we know that mu already is 0.25, right? So we've got 2 times 0.25 n equals 15 newtons, just taking the 15 across the other side. Therefore n is going to equal to 15 newtons divided by, well, 2 times 0.25 is just going to be 0.5. Yeah? 0.5. Divide both sides by that, and we're going to get 30 newtons. So we know from this that n has to be equal to 30 newtons. So the normal reaction force that has to happen, it has to be 30 newtons pushing on this side, 30 newtons, as you would if you're pushing 30 newtons on this side, it has to be 30 newtons coming on the other side, to stop this 15 newton book from sliding downhill like that. Because the surface is relatively slippery, indicated by the frictional coefficient of 0.25. Does that make sense? Alright, hope you enjoyed that.